Most of my experience in forage sampling from a research standpoint and a practical standpoint has been with baled hay sampling. When I was a graduate student long ago, I used to operate the NIRS hay testing laboratory, which was called the Rover Lab. So I kind of learned about extension and learned, had a lot of experience in working with growers on pulling dry hay samples. So we'll probably spend most of the time talking about that, but I will attempt to talk a bit about sampling corn silage and small grains per Matt's request. Kind of to begin with, I would like to stress one important component when you're looking at determining how to sample. It's more about wet type products versus dry products. So baled hay is very different than silage. And so I'll try and focus in on that. It's less about whether it's alfalfa, corn, or small grains. It has more to do with dry versus wet. Grant spent a great deal of time talking about sampling, the basics as far as being representative. And I put this slide in just as a reminder, most all of us are scientists. As we approach sampling, we need to be thinking about it from the scientific method standpoint. One of the very first chemistry classes I had, my professor spent a lot of time talking about the differences between precision and accuracy. And so on the far left, you have precision, but you don't have accuracy. So this might be the case if you take a really good sample and the lab you happen to send it to had a problem with their equipment and gave you bad results. Whereas on the far right, if you have your sampling technique down and the lab that is doing the analysis is participating in an accreditation program and their accuracy is continually evaluated, then you have both precision and accuracy. So, Grant went to a lot of detail in his presentation, and that's about all. As we approach sampling forages, we always ask the question, why? Obvious answers. Forage analysis gives us information to market hay or corn silage or small grains, whatever it may be. Helps us establish the purpose of the forage. Is it suitable for dairy, hay, or feeder or export? It gives us information to establish price. It gives us the specific numbers to balance least cost rations for livestock. But again, as we approach thinking about sampling and evaluating forages, there's two primary methods: the objective method, which is an analyzed or tested method, which is a factual evaluation method. This is done primarily on forages by wet chemistry methods or by near-infrared spectrophotometry or NIRS. The other method is subjective, which is visual or smell. I think many of our growers and you can look at the alfalfa and you can smell it and you can tell quite a bit about it, but it's very subjective based on the individual eye and the individual nose, and it's not factual, and there's always bias that's built into it. So forage testing is the only sure way to get factual information. I would like to state that it's better to have a correctly pulled sample and an analysis from a correctly pulled sample than to have analysis from a biased sample. Analysis from biased sample is worse than no sample analysis at all, because you'll base the information on what seems to be a correct analysis, and it won't be correct. So sampling protocol, we've talked quite a bit about the basics already. Again, Grant, most of his presentation talked about this, but when it comes to forages, as you think about being representative, accurate, and precise that we've addressed, the first thing you want to do, whether it's silage or alfalfa, is to identify a lot. Not a lot, but a lot, L-O-T. A lot of forage is forage that has been treated the same. In the case of baled alfalfa, it'll come off in the same field. It's cut the same day, about the same time. It's baled the same day or about the same time of day with similar dew content. Soil type will be the same. Irrigation will be the same, etc. Anytime there's variation within a field or variation within the forage that's being produced, it needs to be identified and separated and sampled separately. So just as you would sample two different soil types in a field that Grant explained, you want to sample different forage types separately, and don't try to blend a sample, or you won't have a good analysis. Most of these recommendations you'll find on the National Forage Testing Association website. In the chat box, I've copied in links to that association, as well as several other links, including some videos that you can look at on your own time. So one of the recommendations from the National Forage Testing Lab Association is not to pull samples on more than about 200 tons of hay at a time in a specific lot. And there's kind of a reason for that. You think about it, you're only going to be analyzing about a tablespoon amount of the sampled forage through an NIR machine or through a wet chemistry. And so you think about that. Here on the left you've got a large stack of alfalfa, and you have to have portions of as many of those bales as possible end up in the cup here on the bottom photograph on the NIRS lab. So sampling is correctly taken sample is very important to make sure that you get good results. Again, using Grant's words, garbage in, garbage out. But if you take a good representative sample, then the analysis that you get will be useful. When to take the the forage sample? In the case of baled hay, it's after you've gone through about a 30 sweat period. Alfalfa does go through some chemical changes as it's sweating or curing in the bale. Silage goes through a fermentation process, which takes 30 or 40 days. So you don't want to sample too quickly if you're selling the forage or feeding it, sampling it and having it analyzed close to the point of sale or close to the time of feeding is preferred. In the case of baled hay samples, you want to take 20 cores per sample. Those 20 cores become a composite sample. You want to grab samples are unacceptable when sampling dry forage of any type, especially alfalfa hay. As you grab a sample in your hand, the leaves and the stems are always dry and shattered and separate. And if you lose the leaves and the fines out of the grab sample as you're taking it, you'll immediately have a biased sample. So you want to use a good soil sampler. I'll address that in a minute. On the USU analytical lab, there is a handout that talks about splitting dry samples. You cannot accurately split dry samples contrary to the instructions that are on the handout that is there. Dry samples should go through a pre-grinding, which can be done by a Wiley mill. But if you do a dry split sample, inevitably you will have a differential separation of fines versus coarse stems, and you'll bias the sample before it ever goes to the lab. Here's a Wiley mill, which are used commonly for research and testing lab purposes. Has a very coarse, large sieve-sized screen in it, so you can very quickly grind large samples. And once you've got a pre-ground large sample, they can do a split. The UD mill shown here in the lower right has a very, very fine sieve screen on it. And that is the way the technology of the NIR is all based on a very fine flour or powder-like consistency of the grind on the sample. So you have to, large samples can go through a two-step grinding process to help reduce large sample sizes. So back to the 20 cores per sample or the composite sample. I want to spend a moment and talk about random sampling. As with soil sampling and all other types of sampling, random sampling is an important concept, but that does not mean that you cannot use a pattern. I was taught long ago as a technician running the NIR lab and also as a student, that as long as you follow a designated pattern as you pull the sample, whether it's from a stack or from a field, if you follow that pattern, that helps you avoid the inclination to sample just the good spots or to skip the bad spots, etc. So when you have stacked bales of hay, selecting a pattern is still taking a random sample, and I'll show that in just a moment with some photographs. When sampling baled hay, it's obviously you take it through the butt end of the bale, not on the side. In the case of a round bale, you go through the folded side or the outside surface of the round bale. Again, with square bales, you go in the center of the bale, not the top, not the bottom, but in the center. The core, the sampler should go straight in, and then using a core or a sampler that has a collection chamber in it, you should plunge the individual core between every collection, or in the case of using the single core Penn State sampler, you need to dump the core after it's taken each time to prevent back pressure in the tube. So many different bale sizes are shown here. Your large squares on the upper left, your small two string bales in the middle. You have your very dense double compressed 1-ton bales on the far right, which are extremely hard to take a good sample of because they're so tight. You have three string bales in the bottom, so you have to kind of adapt and adjust to the circumstances. But before you really start pulling the sample, the first thing to do is identify a lot. And sometimes you can see that by looking at a stack of hay. So this is a stack that I looked at a few years ago when we were preparing this study. On the upper left, you can see 3 bales here, actually 5 bales that are a different color than the rest. And when you look dead on, this second bale up from the bottom, you can see that one half of the bale is light colored and the right half of the bale is a darker color. So obviously this is where they changed fields or changed cutting times. You have bleached hay on the left and not so bleached hay on the right. So identified by this red placard, you would not want to sample this odd looking bales separate from the rest of the stack. So look for differences, talk to the grower, and make sure that you can identify the lot of hay. And again, a lot means hay that has had similar treatment. The photo on the bottom right shows the center of the bale, the little fluorescent flag going straight in. The upper photo shows a tube going down on an angle, which is not following protocol. The special circumstances on the right, you can see there's a guy wire supporting the hay cover building. And the individual that sampled this stack before I got there had moved over to the left and upper quarter of the bale, taking the core there, which will build in biases into the sample because of the position in the bale. I'll come back to that concept again in a few minutes, but here's maybe an example of some ways you could find a random pattern that you could use on a stack of hay. You know, if you're only sampling maybe a couple of hundred bales of small string, 2-wire strings or 2 string bales in the upper right, maybe you're pulling 3 or 4 cores out of each bale wagon load. If you're sampling, you know, a stack that's got, you know, 500 or 600 tons in it, like the one on the left, then maybe go in a zigzaggy fashion down through the side. Or the lower photo on the lower right, again, down the side of the stack. Now, the disadvantage in the sampling method on both of these lower photos is you're not sampling this upper 3 rows of bales, which is, again, a way to build bias into the sample. It would require getting on a ladder or getting in a front end loader, which would be a better way to have a more complete zigzag fashion up and along the side of the stack, but there's a certain amount of hazard built into that. So just be aware of those nuances on how to pull a sample. Quickly, you want to sample in the butt end of the bale, straight in, using an electric drill, Some of the newer cordless drills do work. They have to have some pretty good horsepower or torque to be able to pull most of the samplers in, especially tight bales. Plunge each core between taking a core. NIRS, I've talked a little bit about that. Sample handling, you want your sample sizes to be approximately ½ pound, which is about 200 grams, about a ½ gallon in size. Large samples, labs will either charge a surcharge for grinding, or if they do a split at the lab and have not done a pre-grinding, they can actually bias your sample right at the lab. So pre-grinding is important for both those who are taking the samples as well as labs that are processing them, to make sure that you can properly split a dry sample, but only after it's been pre-ground. Sample bags were mentioned by Matt earlier. I always use Ziploc bags, but I always get freezer bags. Yeah, freezer bags have a thicker, heavier gauge plastic, and they will handle the sharp stems on the alfalfa. So when you go to the store to get your Ziploc bags, get freezer bags that are thick, which handle the sample much better. Always take your sample, your hay samples, keep it cool, keep it dry. Don't throw it on the dashboard of the truck or put it in the front cab of the pickup with the windows rolled up in the middle of July, when you can actually cook the sample inside the truck just by the way that you handle it. You always want to have your sample analyzed as soon as possible after you take it through a National Forage Testing Association certified lab, whether it's wet chemistry or NIRS. I'll skip this a little bit. We did a Bale study a couple of years ago where we looked at different hay samplers. There's many hay samplers on the market. These are just an example of some of them. I could, another day I could give you information about the good ones and the bad ones. Most hay samplers have some weaknesses, but a couple of things you want to look for. The basics of samplers needs to have a hollow tube. It should be 12 to 24 inches long. It should not be an auger, open type auger. It needs to be a tube. The cutting diameter, the research is all based on a 3/8 minimum and a 3/4 inch diameter maximum size sample. The 3/4 inch size diameter common with the Penn State sampler that's shown on the lower right. And then also here, this one on the middle right, this is the newer Frontier mills. They take very, very large samples, and inevitably when you take the 20 cores per sample, you'll have almost a gallon of material, and the sample will need to be pre-ground. So going back to the tube, the inside the collection tube, if the cutting tip is slightly smaller inside diameter than the inside diameter of the collection tube, it will allow the sample to easily fall down the collection tube and not get bound up in it. Some of the samplers do not have a tip at all, and they have the same diameter tube all the way through, and samples often get plugged in them. Tips need to be sharpenable. They come smooth cutting tips, scalloped, serrated, and the finely serrated are helpful. But the most important part of the tip is make sure it's sharp. That will help cut through the stems and give you a representative sample while that tube is going into the bale. Extra features that make the chore a lot easier is a drill-operated sampler that you can run in and out of the bale fairly quickly. Having the collection chamber like this star sampler in the middle right, the blue collections chamber, they'll hold, many of them will hold up to about 20 cores, which is the standard. That makes the job a lot easier. And having the spiral assist, That's the fluting that you can see in this upper right photograph. I actually patented that a number of years ago on the design of the Utah Hay Sampler that we developed at Utah State University when I was a graduate student. And since many of the manufactured samplers now use that same design. So again, here's the blue or the star sampler, which I believe is probably the best one on the market. It's almost $450. It's very expensive, but it's very good, and it makes the sampling chore much easier. One more quick thing I'll mention: when you think about the bale chamber on a small baler, and the hay's a little bit dry, every time that plunger compresses the alfalfa as it's stuffed into the bale making chamber, the leaves shatter and fall to the bottom. So as part of our study, we looked at a bale consistency study. We used the star sampler. We took 25 cores out of each bale. We had 4 different bales to give us replications, and we sampled it in a grid pattern, 5 rows with 5 columns. Each core in each bale was analyzed and averaged separately. This is the result, and as you might expect, the top cores all had a lower relative feed value, or I'm sorry, had a, let's see if I'm going to, I need to relook at this. The bottom cores had the highest relative feed value, shown by 162%, or I'm sorry, 182. When you look at 182, 184, 183, these are all in the upper half of the bale. So the upper half of the bale has a higher relative feed value than the lower half of the bale, just due to the settling out of stems during the baling process. I'm not sure if video will play, but this I'm going to switch briefly and talk about sampling silages. Again, silages are wet, so it's a different method. You think about how the silages have been put in. You've got different lifts. Sampling devices don't work in silage, so taking grab samples are okay. I will actually skip the video here in the interest of time, but essentially you only sample the exposed face of the pit. And then as you pull each grab sample, you scrape off the outer 4 to 6 inches of the surface, and then reach your hand back in and grab an equal size handful of forage from multiple locations on the face of the pit. Use a W pattern or an M pattern and sample maybe 9 to 12 places on the face of the pit. Doing bags, similar thing. You can on your samples on sampling silage bags, you can sample just the open area, but if you have permission from the grower, you can take a grab sample along the length of the plastic tube. You need to kind of back up and as you look at the bag, you want to look for how it's been labeled. Look for differences in lots of feed that's been put in that bag, whether it's alfalfa, silage, corn silage, small grain. You want to sample forage that has been treated the same, had the same treatment. So you can go down the side of the silage bag, cut a triangle shape, about 6-inch triangle, cut the upper 2 sides, but leave the bottom intact, creating a flap, dig out 4 to 6 inches of the surface of the silage. Take your equal handful size of the silage, put it in your bucket, and then immediately close the flap back up and make sure the tape you have will securely hold that flap back in place, or it will contribute to spoilage in that bag as air will be introduced into the bag. It's, as I've mentioned before, with taking the samples out of a pit, when taking samples out of a silage bag, it's okay to split the sample because it's wet and you don't have the fine and the coarse separation. But it's important as you split those composite samples, mix them thoroughly in the bucket. And once they've been mixed thoroughly, then follow the lab instructions and ship the samples to the lab. Most important thing is you want to keep those samples cool. If you're shipping them in the middle of the summer, you don't want them sitting in a mail truck or in the mail room at USU for a week. They might not appreciate it, but you want that sample to be kept cold to prevent the oxygen based fermentation processes that will change the character of the sample. It's best if you ship them overnight. Most of the labs will provide instructions on how to do that. This is a video that, again, I won't show. It's from Rock River Labs that provides forage testing. They show how to take composite samples from the face of a silage bag. And they don't, in their situation, recommend pulling samples through the side of the bag for the reasons that I just mentioned. But when you pull a sample only from the face of a silage bag, you're only getting an analysis on a very small portion of the silage, and it does not tell you very much that is useful for marketing the silage or balancing a ration. In order to have adequate information, you need to take multiple cores through the side, along the side of the bag. Other interesting challenges are sampling baled silage, which is bales that are baled wet and stuffed in various tubes or wrapped, and usually silage or some type of a haze sampler will not work well because the sample is wet. This is just a summary again, which I'll kind of just briefly cover, and then I'll end. Make sure that it's a representative sample. You want a sample forage that has been treated the same. In the case of dry hay, 200 tons at a time maximum per lot. You want to sample the hay after it's gone through a sweat period, or in the case of silage after it's fermented, which is 30 or 40 day process, then also close to sale. In the case of dry hay, 20 cores is the bare bones minimum. You may be told to sample, it's okay to sample less cores, but the less cores you take, the less precise and the less accurate sample you'll ultimately have. Now, I'm not going to recommend you take 40 cores, but the more cores you take, the more likely you are to have an accurate sample. And remember that a pattern of sampling is still a random sample, and it's probably the easiest way to get a random sample out of a stack of baled hay is to choose the same bale in the same row or in some type of pattern, so you're just sampling in a pattern. That way you can avoid the bias by choosing a good bale or a bad bale. In the case of baled hay, again, butt end of the bale, center of the bale, not the top or the bottom, due to the settling out and the different quality you will have in the top of the bale versus the bottom of the bale. Core sampler should go straight in, and then you want to plunge the core between every, or the core that you take between every core to eliminate back pressure in the tube. Here's the resource links, and I've posted those on the website, and